Okay, so I've gotten a couple questions on how to do the second part, basically, of the task card, so I thought I'd go through and explain it. So there's one formula that we really didn't talk about. It's called continuously compounded, and so this is the equation that you're going to need. It's A equals PE to the RT. So everything is a variable besides E. E is a number. So I'll explain what that is. But A is going to be your final amount, P is the initial amount, R is your rate, T is your time. So the only difference is that I'm not adding it to one. This is something that's continuously happening. So as something grows, we're going to take that new number and it's going to grow further. Okay? So you kind of have to do this twice in order to simplify. So if we read the first part of number 18, for instance, it says that Kristen starts an experiment with 7,500 bacteria cells. That's my initial amount. That means P is going to be equal to 7,500. This is after 4 hours, which will be my time. I have 23,000 cells. Okay, so that's its own statement. I'm going to ignore the second part of that question. So I know that my A is going to be equal to 23,000. So the only thing that I don't have would be my rate. So this is what I have so far. Okay, we're going to use this information and we're going to plug it into this equation, and then we're going to solve for the missing variable, which in this case is R. We know my final amount is 23,000. We know my rate is 7,500, or excuse me, my P is 7,500. My E is a number, so we're going to leave it. I don't know R, but I do know that time is 4. So what we're going to do is we're going to simplify this equation to kind of get the E essentially by itself. So step one is I'm going to divide everything by 7,500. Okay, and so when I divide this, I'm going to get a decimal. So if I do 23,000 divided by 7,500, I'm going to get a decimal of 3.0667, which if we're going to be accurate, I'm just going to convert this into a fraction. So I'm going to go math, enter, enter, and I'm going to get the fraction of 46 over 15. And then basically R times 4 is the same thing as 4R. So this is exponential form. I'm going to rewrite this in log form. I'm going to get log base E of 46 over 15 is equal to my 4R. If you wanted to, you could rewrite it in this direction so that my exponent is on the left side. We know that log E is the same thing as natural log. And then last but not least, to get my rate by itself, I'm going to divide everything by 4. So I'm going to get a rate of, and let's plug this into our calculator. So I'll do it on this screen so you can follow along with me. I'll do alpha x to get a fraction. I'll do natural log of 46 divided by 15. Make sure you close that parenthesis. Arrow down, and then I'm dividing this whole thing by 4. And I'm going to get a rate of about 0.28. Okay, so that only helped me with the first part of that equation. I now need to look at the bottom part. If we were to go through and start with our amount of 7,500, I know my time is going to be 12 hours, and I now know my rate of 0.28. I'm trying to figure out how many cells we would have after that time. So if I go back to my equation, here's my new one. I'm going to have P is 7,500, my time is 12, my R is 0.28. I'm going to plug it back into this exact same equation and solve. I'm going to say A is equal to 7,500 E to the 0.28 times 12. Now, my equation or numbers may be slightly different than what is on the answer key because I'm rounding my R value. If you leave the R value as it is, which I'll show you on here, then you'll get the exact same answer as the answer key. So I'm going to type in my 7,500. To get E to pop up, I'm going to hit the second natural log, and I'm raising it to my rate. So you can either type in the 0.28, or if you do second answer, that's going to take this answer of this entire decimal, plug it in right here, and then I have to multiply it by 12. And this will give me the answer that's going to show up in the answer key. If you just were to do the 0.28, you'll get a decimal that's very similar, but you're going to notice it's going to be slightly different than this. So in this case, I know that I'm going to have 216,302 cells. So that would be my final answer for number 18. Okay, I'm going to go through one more with you just to make sure you understand the concept of what it is, and then I think you'll get the idea from here. Okay, so let's just look at number 19. So mitosis is a process in which one cell divides into two. I don't know how to say that, so I'm going to go E. coli is one of the fastest growing bacteria. It can reproduce itself in 15 minutes. Okay, and the question right there. So it says it divides a cell into two. That means that I'm initially starting with one cell, so this is number 19. It's going to split into two, so that means my final would be 2. Okay, it says that this happens in 15 minutes, so we know R is going to, or not R, we don't know R, but we know T is going to be 15. So we're going to plug it into my A equals P e to the RT, and we're going to solve for the rate. So I'm going to have 2 equals 1 e to the R times 15. Pretend that looks beautiful, because it's not. Technically, I would divide both sides by 1 as a habit. I'm going to get 2 is equal to e to the 15r. Once again, if that bugs you, you can do e to the 15r on the left and your 2 on the right. I'm going to rewrite this. I'm going to have log base e of 2 is equal to 15r. We know my log base e is the same thing as natural log. And then to get the r by itself, I'll divide everything by 15 to get a rate of, and let's plug this into our calculator. I'll do alpha x, natural log of 2 divided by 15. I'm going to get a rate of 0.046. Okay, now going back to the second part of it, it says if you begin with 1 E. coli cell, how many cells will there be in 1 hour? Okay, so this is the second part. P is still going to be 1. My A is my question mark. My R is the 0.046. And my time is going to be 1 hour. Now, if we were to go back, we know that this up here is 15 minutes. They need to be the same unit. So since I start with units of minutes, my time also needs to have units of minutes. So if I want 1 hour, we know that there are 60 minutes. So I would use my time as 60 minutes. So make sure your units are matching. Okay, so I'm going to plug this in. I'm going to say A equals 1e to the 0.046 times 60. So when I go to my calculator, I'll do 1 times second natural log. I'm going to do second answer, so I get this whole decimal in my exponent, times 60, and that's going to equal 16. You're going to follow this same idea for the rest of the questions. So try them out, and I will go through a question and answer session on Monday, since Monday is supposed to be more of a catch-up day. All right, let me know if you have any other questions.